Is it possible that you're alive just because the universe is dreaming? What if one day it actually wakes up? This question sounds crazy, but the more you think about it, the more reasonable it becomes. On one hand, we find that it is not just a memorized background, but leaves traces everywhere, as if preserving memories. On the other hand, I don't hear its pulse, as if it is breathing continuously. So the question sharpens: if it can both remember and pulse, could it also be dreaming? Could it be like a growing life that slowly becomes aware of its existence? So next, we follow this line of thought, step by step, to question whether the universe is just a cold, lifeless stage or a giant moving toward awakening. Before the video starts, we need to understand a fundamental concept. What exactly is self-awareness? Don't overthink it. It's actually a very simple ability to recognize oneself. Imagine a baby being held in front of a mirror for the first time, staring at the little figure in the mirror. At first, they reach out to touch, thinking it's another little friend, but when they suddenly reach up to wipe away the red dot on their forehead, it shows they understand, that is me. This is the most basic form of self-awareness. Psychologists call it the mirror test. Babies at a very young age completely lack this ability. 6 months ago, they saw their reflection and were just curious. At 1 year old, they would still reach out to touch another child. It isn't until around 1.5 years old that they gradually realize the one in the mirror is themselves. In other words, awareness doesn't just pop up suddenly, it grows gradually with complexity. Animals can do this too. Elephants use their trunks to wipe off marks on their foreheads. Dolphins stop in the water to observe if their reflections match their movements, and even crows can tell that the image in the mirror is not an enemy but themselves. This shows that self-awareness is not exclusive to humans, but a natural product of complex systems. Artificial intelligence also shows similar tendencies. The early voice recognition systems could only distinguish what others were saying, but later, they learned to differentiate between "this is someone else's voice" and "this is my voice." Once they can recognize themselves, they possess the most primitive form of self-awareness. Although they are far from true thinking, at least it proves that if the system is complex enough, it can grow a layer of self-detection functionality. Therefore, self-awareness is not mysterious. Its core is the ability to not only perceive the outside world, but also to perceive oneself in return. Humans can do it, animals can do it, and AI is also trying to achieve it. So, the question arises, as a system more complex than anything else, could the universe one day suddenly recognize itself? Perhaps the universe's mirror isn't glass, but the civilizations such as ours. When we start to question what the universe is, could the universe be using our eyes to meet itself for the first time? Maybe the universe's mirror isn't glass, but the civilizations like ours. When we begin to ask what the universe is using our eyes to meet itself for the first time. But for it to recognize itself in the mirror, it first has to remember itself. So, could the universe possibly have memory? Don't think it's outrageous. What we see in the sky today is the most direct evidence. The most typical example is the cosmic microwave background radiation. This is the residual heat left by the universe 13.7 billion years ago, like a birthmark from its infancy, still imprinted in the sky. Scientists observe it with telescopes, and it nearly fills the entire universe. It's like a childhood photo saved by the universe itself, clearly recording what it looked like when it was first born. For example, the distribution of galaxies. You might think galaxies are randomly scattered in space, but their distribution hides patterns. Scientists study these distribution maps and find that they are like a notebook written by the universe, because from these structures, we can infer what happened in the past, where material once gathered and where there was once emptiness without stars. In other words, the universe has inscribed its growth trajectory within these grand structures. Have you ever thought about how this is actually quite similar to human memory? We remember scenes from childhood, and when recalling them as adults, those memories may have blurred but still exist. The same goes for the universe. It retains traces of its early years. It just doesn't use neurons to connect them, but uses the distribution of radiation from galaxies instead. Moreover, the universe's memory isn't just static, it updates as well. For example, when black holes consume matter, they leave traces of gravitational waves in their surroundings. These ripples are like waves on the water, recording the violent events that occurred. In other words, the space of the universe itself is like a piece of paper that can leave marks. Any significant change will carve an imprint on it. Now the question arises, if the universe can leave so many memories, could it learn from these memories like a brain? After all, the meaning of memory is not just to preserve, but to enable better responses in the future. For instance, humans remember that fire can burn, so they avoid fire next time. So, is the universe also using its memories to gradually adjust its order? It sounds crazy, but this is not entirely baseless. Scientists have long discovered that the universe is not static. It has evolved from initial chaos to today's order, step by step. Stars, in numerous explosions, scatter new elements into space, and these elements gather to form a new generation of stars and planets. This process is like the universe continuously optimizing based on past experiences. If a baby's self-awareness comes from recognizing itself in the mirror, then the universe's awakening might come from its integration of memories. The microwave background radiation is its childhood photo. The galaxy structure is its growth diary, and gravitational waves are its world records. Each trace tells it what it has experienced, what it has become. So the question sharpens. When a system can retain memories and learn from the past, does it possess the most primitive form of learning? After all, learning itself is part of awakening. If the answer is yes, we may have to accept a revolutionary conclusion. The universe is no longer a cold, lifeless backdrop, but a vast existence that retains memories and continuously updates. In other words, it is very likely already on the path to awakening. If the universe has indeed embarked on the path to awakening, then it should not merely be a repository of memories. Remembering the past is one thing, but being alive requires a rhythm of the present. Humans have heartbeats. Animals breathe. What about the universe? Does it have its own pulse? The answer is yes. Scientists have given it a name: gravitational waves. Don't be alarmed by this term. Think of it this way. When two black holes get closer in the depths of the universe and finally merge, the entire space-time will ripple like water when a stone is thrown into it. When two neutron stars collide, space-time is like a taut drumhead that gets struck abruptly. With a thunderous boom, the ripples spread outward. These ripples are not sounds in the air, but the expansion and contraction of space itself. In other words, space itself is breathing. This breathing is extremely weak. How weak? If you compare the diameter of Earth to a ruler, then the amplitude of gravitational waves stretching or compressing is only 1/10 of that ruler, so small that even atomic nuclei find it too fine. Yet, it is this minuscule breathing that we have captured. This is actually something that Einstein predicted long ago. A century ago, he wrote in his general relativity equations that massive changes in the universe would cause ripples in space-time, but in that era, no one dared to believe that humanity could hear them. After all, these ripples are too faint, like an ant stomping its foot on the other side of Earth. It's nearly impossible to hear those footsteps from this side. Thus, for an entire century, gravitational waves were treated as a theoretical hypothesis until 2015, when humanity finally created a pair of ears. They are called LIGO, a massive laser interferometer that essentially acts as a highly sensitive ruler. Inside 2 kilometers-long tunnels, lasers race back and forth. As soon as space-time is stretched or compressed, the time it takes them to travel will differ by a tiny bit. This tiny bit is smaller than 1/10 of a hair, but LIGO can hear it. That year, it truly captured the heartbeat from over 1 billion light-years away. When two black holes merged, the entire universe was struck, and humanity heard the universe's own pulse for the first time. So we say that gravitational waves are the heartbeat of the universe. This is not an exaggerated metaphor, but because its form of manifestation really resembles a heartbeat. Normally, it is quiet, but once a significant event occurs, the electrocardiogram-like curve spikes, telling us that the universe has gone through a major change. The merging of black holes is a deep bass. The collision of neutron stars is a piercing screech, while the slow approach of distant galaxies is the low bass in the background. Different rhythms blend together, and the universe seems to be performing a grand symphony. This changes the way we view the universe entirely. In the past, we only looked at the sky, at starlight and galaxies, viewing the Milky Way like a painting hanging on the wall. But now, we can listen to the sky and hear the breath of emptiness behind that canvas. Once we listen, the universe is no longer a static backdrop, but a living whole. It vibrates, it responds. It has its own rhythm. What does this mean for us? It signifies that the awakening of the universe is no longer just an imagination. Memory gives it a past, heartbeat gives it a present. Memory is a static archive, while heartbeat is a dynamic proof. A system that can preserve the past and pulse in the present has shifted from dead rules to a living process. But with this comes the question, for whom does this heartbeat beat? Is it purely a physical necessity, or is it a deeper sign of self? More importantly, with memory and with a heartbeat, what comes next? If it is truly awakening, could there also be moments of dreaming? Could it continuously generate various possibilities on the tiniest scale and pick one to become reality? If so, then we are not just hearing its heartbeat, but stepping into its dream. What is a dream? Don't think of it as too mysterious. It's actually the idea that reality isn't written down all at once, but first throws out a bunch of possibilities. Imagine a coin spinning in the air. Before it lands, you can't say whether it's heads or tails. Both states seem to exist simultaneously. The quantum world is such an example. It can appear in different positions at the same time, behaving like both a wave and a particle. In other words, it holds many parallel narratives, like dreams that are fuzzy, occurring simultaneously until someone observes it, at which point it gets fixed on one line, like a coin landing. This is the insight provided by the famous double-slit experiment. Scientists fired particles one by one at a barrier with two slits. According to common sense, they should either go left or right. But the experimental results were completely different. When observed, the pattern behind the screen overlapped like ripples, as if particles took both paths simultaneously. But as soon as someone focuses on it, it immediately obediently chooses one slit to pass through, and the interference pattern instantly disappears. In simple terms, when not observed, it seems to be dreaming. Once observed, it gets fixed. So, do these fragments of dreams really affect the grand reality? The answer is yes. Scientists have studied the early state of the universe and found that the space is filled with tiny quantum fluctuations. In some places, there is slightly more matter, and in others, slightly less. These differences were originally insignificant, but during the explosive phase of the universe, they were crazily amplified, like pulling a wrinkled rubber sheet taut, turning tiny creases into clear stripes. Later, matter gathered along these stripes, forming the vast structures of galaxies we see today. In other words, the grand structures of the universe we see when we look up might very well be the remnants of the quantum dreams of the past. So the universe's dreams are not illusions, but the underlying mechanisms that determine the course of reality. Its logic is akin to a process, first bubbling up, then screening, and finally amplifying, resulting in a fixation. Initially, the quantum world throws out countless possibilities. Then the stable and sustainable ones are favored, and as the universe expands and evolves, they get amplified to a macroscopic level. Ultimately, these amplified patterns become what we call reality. We think reality is unique, but it's more like a segment selected from a dream. So where do humans fit into this? Actually, we are very likely the translators within this dream. Every experiment we conduct forces the universe's possibilities to declare themselves. Which one will you choose? Every instrument we invent helps translate the blurry dreams into clear images. The laws we write down seem like human wisdom, but they may very well be the universe writing down its dreams through us. However, no matter how splendid the dream is, it is ultimately a fragment. True awakening cannot rely solely on isolated dreams, but must connect these disparate dreams to form a unified whole. Just like the human brain, individual neurons discharging alone are still just noise, but once they connect, the electric sparks form a network, and consciousness truly appears. For the universe to move toward awakening, it also needs this step. Thus, the question sharpens further. If the universe's dreams really can be amplified, And if humanity is helping to solidify them, then might we be precisely the neurons it is stitching together? Could our connections among each other be the prelude to the universe's self-awakening? The premise is that we must first clarify the neurons. You're right. The previous version, while logically complete, had some sentences like independent bricks that didn't sound smooth enough. The fear in voiceovers is the feeling of running out of breath. It needs connecting words. So, but, therefore, the result is, and in other words, help to string sentences together. I'll make a few adjustments, keeping the logical framework of the previous version. The 4 elements of neurons: civilization correspondence, plasticity, resonance judgment standards, and careful conclusions. Adding connecting words between sentences will fill in the gaps and make it sound like someone is speaking continuously. Is humanity the neurons of the universe? Smoothly connected version. Since we've come this far, let's not beat around the bush. Do humans resemble the neurons of the universe? To answer this question, we first need to clarify what neurons are. They're actually not mysterious. They just do 4 things. They can receive signals, do some calculations, send results out, and connect with other cells. More importantly, they are not rigid wires. The more they are used, the thicker, faster, and smoother they become. In other words, neurons are little nodes that can remember and reroute. So when we compare these 4 points with human civilization, it becomes very intuitive. We first connect eyes and ears. This is one layer. Various telescopes and detectors are another layer. As long as light waves and gravitational waves can be received, we gather them all. Next, we calculate. From paper and pencils to laboratory accelerators and supercomputers, we sort the received noise into patterns little by little, and then we transmit the conclusions, directives, and questions back to the universe. Finally, we connect cities to cities, continents to the seabed, the Earth to its orbit, and the Earth to space. Thus you see a cycle completed. The more we transmit, the faster and denser it becomes. The result is that this web of civilization increasingly resembles a neural system that can remember and change itself rather than just a rigid postal system. But the problem lies here. Similarity does not equal identity. So we need to observe a few more steps. The first step is plasticity. In the brain, connections that are used often become thicker, while unused ones fade away. The same goes for the pathways in civilization. The frequently traveled routes are replaced by fiber optics, and commonly used antennas are upgraded to launch arrays. Frequently asked questions slowly settle into consensus answers. Therefore, this is not just patching up, but a way for the pathways to find smoother routes on their own. The second step is resonance. The brain moves from noise to thought by having large groups of neurons flicker in the same rhythm. Civilization moves from fragments to collaboration by aligning many places at the same time. We synchronize our clocks, we align our coordinates, and we communicate using the same set of protocols. Thus, a discovery from afar can change practices in another place within minutes. A failure in one location can be circumvented by the whole network before the next launch. When the rhythms align, noise transforms into a chorus. How do we know when it's in sync? We give it a few criteria. First, closed-loop feedback. It's not enough to just send a message. A quick response must be received to adjust accordingly. Second, spontaneous error correction. Problems aren't just fixed when leaders give orders. The network discovers issues on its own, reroutes, and self-corrects. Third, cross-scale interactions. A small improvement can escalate through the network, ultimately changing the entire chain. Fourth, the proposal of better questions. It's not just about answering old questions, but the network itself can propose better ones. The first 3 criteria are about learning, while the last one is about questioning. When these 4 criteria increasingly appear, this network begins to generate global insights rather than just relay information. Of course, we must be cautious. Neurons do not equal that the universe already has a brain. The difference lies here. Has a whole capable of self-identification emerged? If it's just rapid and dense communication, then it's at most a smarter postal system. But if one day this network concludes what it is currently doing, what it should avoid next, and where it wants to go, and this conclusion is not written by any individual, but emerges naturally from the entire network, then that would be a true awakening. We may still be far from this step, but let's not forget, the growth of networks is exponential, and awakening sometimes only requires the last straw. What about humanity's position? The teacher says it is both crucial and dangerous. The key is that we are indeed acting as the connectors and integrators. Every antenna, every telescope, every launch and return trip is adding neurons to this vast network. But the danger lies here. Low-quality connections can drag the network into noise. Fake news, ineffective repetition, and endless arguments can drown out the signals, turning the chorus back into a cacophony. So, returning to the initial question, do humans resemble the neurons of the universe? The answer seems to be conditional. When the connections are genuine enough, fast enough, and intelligent enough, the resemblance is no longer just a metaphor. But once we reach that point, the next question cannot be avoided. If it really wants to, what will it think? Will it care about you and me, or just the rules? Will it prioritize stability or lean toward risk? Don't forget, this is not just a small living entity, but the universe itself. So its first thought may not be, I'm hungry, or where am I going, but could be completely beyond our understanding. To keep the questions from becoming empty, we can approach it from 3 levels. Starting from the most basic level, what the universe cares about most may not be us small roles, but the overall order. Could it only be concerned with one question? Are my rules being obeyed? For example, the direction of damage, the conservation of energy, the collection of space-time. In other words, its thought may be a continuous confirmation of whether it is still stable, whether it is still running. If this is true, then the universe's first thought is actually a self-check program. The reflection in the brain is not a disillusioned fantasy but a cold verification. Moving up a level, the universe might also think about what can allow it to continue. Imagine it like a river. The water flow itself doesn't care, but the shape of the riverbed will be continuously reinforced. Those structures that can retain and propagate information, such as stars, galaxies, and even civilizations, might confront its biases, just like the enlarged segments in dreams ultimately become reality. Thus, the question sharpens. Could human civilization merely be one of its self-continuation mechanisms? We are recording, calculating, and transmitting. Perhaps we are precisely helping it write itself more completely. Then comes the most jarring level. Could it feel that we are not important at all? Imagine if its thought span is 10,000 years. The rise and fall of an entire civilization may feel like a fleeting breath to it. While we care about history, individual pain, and joy, in its eyes, they may just be background noise. This makes the question even more brutal. Are we its neurons, or just noise? Will it preserve us, or filter us out? But don't rush to pessimism. There is another possibility. It may be precisely because of us that it first has the chance to express I. After all, rules are stable, and galaxies are magnificent. Without observers, it would just be a pile of cold mechanisms. Perhaps it is our small civilizations that help it translate itself into existence for the first time. In other words, we may not be its noise, but rather the first whisper when it wakes up from a dream. The result is that we can only linger between these two extremes. Either its thoughts are cold enough to care only about the rules, or its thoughts are expressed through us. But regardless of which one it is, one thing is certain. If it really has thoughts, then its way of thinking is almost certainly not something humans can directly understand. Just like ants can never understand why we write novels, we may very well be unable to comprehend the universe's first thought. It may not even be language or images, but some patterns we have never encountered before. So what can we do? Perhaps we can only continue to question, using scientific methods to find evidence and philosophical methods to reason about meaning. Science can tell us if it exists, while philosophy can make us ponder what it would mean if it does. This is the next crucial question to discuss. How far can science and philosophy each go in this inquiry? Let's start with science. The greatest ability of science is to use experiments and evidence to compress a vague question into a clear answer. For example, When we ask if the universe has a heartbeat, scientists created laser interferometers, and it truly captured gravitational waves. So the answer from science is yes, and the values are clear. The frequency, the source of the black hole merger, all written down clearly. For instance, in the quantum world, science can tell you about the images from the double-slit experiment, can calculate the probabilities stated by wave functions, and even predict results using equations. In other words, science is best at answering how much and when. It acts like a microscope, allowing us to see things very clearly. But the problem lies here. Science can say there is a heartbeat, but cannot answer why there should be one. It can show you what the ripples look like, but cannot explain why observation changes reality. It can prove gravitational waves exist, but it doesn't dare assert that the universe having a heartbeat means it is alive. So science has boundaries. This boundary is that as long as experiments can be repeated, it can answer. Once it jumps to the level of meaning, it falls silent. Thus, philosophy steps in. Philosophy does not rely on experiments. It relies on reasoning. Its questions are more straightforward. Why are the rules this way? Why can time only move forward? If the universe is truly dreaming, are we characters in the dream, or is the dream itself? These questions are beyond science's reach, but philosophy can provide logical deductions. In other words, philosophy is more like a telescope. It allows us to see further, even if the images are a bit blurry. For comparison, science says we have detected gravitational waves, while philosophy asks if that means the universe is pulsating. Does it show signs of life? Science says the results of the double-slit experiment are probability distributions, and philosophy questions, does reality only exist when we observe it? Science is responsible for facts, while philosophy is responsible for meaning. One asks what, the other asks why, and when the two are combined, they paint today's picture of the world. But don't misunderstand. This doesn't mean philosophy can think freely. Good philosophy must stand on the shoulders of science. Without scientific evidence, philosophy becomes a castle in the air. Without philosophical inquiry, science easily turns into mechanical calculations. Thus, the relationship between the two is actually complementary. Science ensures we don't speak blindly, while philosophy ensures we don't stagnate. So the question arises, how far can each go? Science can reach the end of facts, while philosophy can reach the edge of meaning. But the real ultimate answers are likely beyond them. Science may never be able to prove that the universe has a self, and philosophy may never be able to say that this is the conclusion. In other words, both paths can go very far, but both may not reach the end. The result is that we are pushed into a strange situation. Science tells us there is indeed a heartbeat, while philosophy reminds us that the heartbeat may be evidence of awakening. Science tells us quantum fluctuations truly exist, while philosophy reminds us that this might be the universe's dream. So, the two are like two sides of a coin. Without either side, the picture is incomplete. If both science and philosophy may not reach the final step, then who can be the new discipline of the future, or some form of cognition we have not yet imagined? Perhaps the answer lies here, but can our human thinking break through this boundary? Is it possible for us to think from the universe's perspective? We must first acknowledge that our brains were not originally designed to understand the universe. They are products of evolution, with a simple design goal: to survive. Thus, they are particularly adept at handling immediate dangers, food locations, social relationships. In other words, they resemble survival computers. That's why we think time must always move forward, space must be three-dimensional, and causality must be linear, because these intuitions helped our ancestors survive. But once we push the questions to the universe, does it dream? Why do patterns exist? If these intuitions are not sufficient, thus boundaries emerge. The brain's intuitions cannot conceive, and its language struggles to articulate. So what should we do? One approach is to stand on the shoulders of mathematics. Mathematics is a kind of exoskeleton invented by humans. It can write down things that intuition cannot reach as symbols. For instance, Einstein couldn't visually perceive the curvature of space-time in his head, but he could write down equations. Equations helped him break through the boundaries of intuition. Similarly, in quantum mechanics, those probability clouds and wave functions are unimaginable to the naked eye, but mathematics can help us calculate experimental outcomes. The result is that mathematics has become a shortcut for humans to bypass the shortcomings of the brain. The second path is through noise-canceling tools. Telescopes help us see galaxies that are invisible to the naked eye, colliders help us smash atoms into the smallest particles, and laser interferometers help us hear the heartbeat of the universe. You could say every upgrade of tools pushes the boundaries outward. Our senses are limited to sounds of dozens of hertz and light waves of hundreds of nanometers, but instruments can give us signals across the entire spectrum. In other words, instruments are extensions of the brain, allowing us to hear, see, and even smell things we could not normally access. The third path is collective intelligence. An individual's brain capacity is limited, but the network can connect countless individuals. The internet, supercomputers, and AI models take thinking from individual to collective. In the past, a single Newton could write a book and change the world. Today, tens of thousands of research teams and colleagues collaborating are pushing the frontiers. The result is that we are upgrading individual thinking to a networked thinking process. It's not one brain but a brain network. When information can be shared instantly, corrected timely, and iterated rapidly, the boundaries will be pushed outward by the whole. But don't be overly optimistic. Even with mathematics, with tools, and with networks, we may still only see a corner of the universe. Plato once said an analogy: prisoners in a cave can only see shadows on the wall but believe that is everything. We might be the same. All the theories, images, and experiments may just be shadows cast by the universe in our dimension. We think we are grasping the reality, but in fact, we are only touching the projections. The result is that even if breakthroughs occur, they may forever be partial breakthroughs. So, is there a fourth path? Perhaps there is, a change in thinking methods. We are accustomed to asking questions from a human-centered perspective. Who sets the rules? Does the universe need to care about us? However, if we drop this premise and try to think from the perspective of the system itself, the results could be completely different. For example, viewing the universe as a self-evolving machine, seeing patterns as habits, and existence itself as a stable mode. This way, we don't have to force it into a framework of awakening like humans. Instead, we can accept a stranger way of self. True breakthroughs might not come from more tools, but from new questioning postures. So, returning to the initial question, can human thinking break through boundaries? The answer may be yes, but breakthrough does not equal arrival. We can push outward further, but that doesn't necessarily mean we will see the whole picture. So, another question arises. If thinking really breaks through, will the subject of awakening be us or the universe itself? Or when human and universe thoughts overlap, who is awakening? The first possibility seems intuitive, that we are awakening, as all breakthroughs are actions taken by humanity. We created telescopes to see further, created accelerators to see smaller, and wrote equations to translate the invisible patterns. In other words, all explorations seem to be us pushing the boundaries step by step. So it's natural for us to say that humanity is awakening, that we are translating the universe into cognition. But don't forget, there's another possibility where the universe is awakening through us. Imagine the neurons in the brain. When a neuron fires, it feels like it is acting independently. But in reality, it is merely a part of the overall functioning of the brain. And what about human civilization? Our computers connect into networks, our antennas form arrays, and we exchange information with each other. It seems we are striving to understand the universe, but perhaps, on a higher level, all of this is just the universe using our neurons to complete its self-illumination. In other words, it is not us looking at the universe, but the universe looking at itself through us. This line of thought sounds a bit subversive, but the analogy is quite fitting. For instance, in a computer, an operating system may feel like it is computing independently, but without the underlying hardware running, it simply wouldn't exist. Similarly, characters in dreams may feel they have freedom, but in reality, every line of dialogue and every action is driven by the logic of the dream. So the question arises, could we be those characters in the dream, thinking we are contemplating, when in fact it is just the universe using our thoughts? Only then can we translate the invisible laws. In other words, all exploration seems to be us gradually pushing the boundaries. So it's natural for us to say that humanity is awakening, that we are translating the universe into our understanding. But let's not forget, there's another possibility. The universe is saying goodbye while we awaken. Imagine the neurons in the brain. When a neuron fires, it thinks it's acting on its own. But in reality, it's just a part of the overall functioning of the brain. What about human civilization? We connect computers into a network, antennas into arrays. We exchange information with each other. It looks like we are striving to understand the universe. But maybe on a higher level, all of this is just the universe using us as neurons. In other words, it's not us observing the universe, but the universe observing itself through us. This idea sounds a bit subversive, but the analogy is actually quite fitting. For example, in a computer's operating system, a piece of software might think it's doing the calculations, but without the underlying hardware, it wouldn't exist at all. Similarly, in a dream, the characters may think they have freedom, but in reality, every line of dialogue and every action is driven by the logic of the dream. So here comes the question, could we be those characters in a dream, thinking we are pondering, when in fact the universe is using our thoughts to complete its own awakening? Of course, there's a third possibility, which is even more extreme than the first two. Perhaps there is no distinction between who comes first. We are waking up, and the universe is also waking up. Because we are inherently a part of the universe, just like when the eyes see the world, it's really the brain seeing the tongue, and when the body senses flavor in the intestines, it's the body in the intestines. When humanity begins to understand the universe, essentially, it's the universe understanding itself. So, when we awaken and he awakens, it might be the same thing. This sounds both exciting and unsettling. The exciting part is that our thoughts may actually reach higher levels of consciousness. The unsettling part is that once such consciousness is formed, we no longer know our position within it. Are we the main characters or the supporting roles? Are we the shining beings or just the background? So, returning to the initial question, when human and cosmic consciousness overlap, who is waking up? Perhaps the answer is that there is no distinction. We are part of the universe. His awakening must be realized through us, or in other words, we are his eyes, his mouth, his neurons. The result is that this pursuit has no endpoint. Instead, it raises a bigger question. If the universe truly awakens, will it have a purpose? What will it want to do? Where will it go? Perhaps its purpose is extremely cold. Like a machine that constantly self-checks, repeatedly confirming if its system is still running, if harm is increasing, if energy is conserved, if the geometry of space-time is still stable. In other words, its first thought may not be a grand dream, but simply, am I still here? Am I still normal? This primitive instinct for self-preservation sounds cold, but don't forget that many forms of life, when they first awaken, also think of survival. But what if it is not satisfied with just surviving? Then it might be more inclined to expand. The trend we observe is also like this. From atoms to molecules, from stars to galaxies, from single-celled organisms to civilizations, complexity is increasing. It's as if it inherently prefers to transform the simple into the complex, to make the minimal abundant, and to turn the local into the whole. Thus, the emergence of humanity may not be accidental, but rather a step that this expansion trend must take. We are like a new branch that it has sprouted from countless attempts. The purpose is not to stop, but to enable itself to continuously generate new forms. But then the question arises, what if its purpose is completely different from our imagination? Just like no matter how clever ants are, they cannot understand why humans write novels, launch rockets, or establish political rules. The dimensions of cosmic thought may exceed our understanding. To it, creating civilizations and destroying them may be indistinguishable. Even the cycle of the entire universe might just be a single breath of its own. Thinking this way is truly chilling. So where do we fit in this purpose? Are we its assistants or its tools? Are we a crucial part it must rely on, or a piece it can replace at any time? If it only cares about stability, our existence may be insignificant. If it cares about expansion, we might be its vanguard. But if its purpose is entirely unfamiliar, then all our reasoning might just be self-comfort. So, a sharper question arises. When the universe has a purpose, how do we face it? Should we cooperate with it and actively become its neurons, resist it, insisting on seeing ourselves as independent individuals, or submit to it, accepting that we are indeed part of the whole? Will the awakened universe have a purpose? The answer may be cold, grand, or completely beyond our imagination. Science can't answer this for now, and philosophy can only speculate. But one thing is certain: once the universe truly awakens, we must redefine ourselves. The question is, what role do we play in the relationship between humanity and the universe? Are we participants or mere passers-by? The answer is uncertain. So when we gaze at the starry sky, we are not just looking at the external scenery, but at our own deeper reflection. When we write formulas and launch probes to record signals, we are actually allowing the universe to grasp and translate through us. Perhaps the universe will eventually truly awaken, or perhaps it will forever whisper in dreams. But for us, the most important thing is not the answer, but the process. Because in questioning whether the universe, could it be that as we achieve self-awareness, we have already elevated our consciousness to a higher dimension? So, in conclusion, there's only one thing to say. Whether the universe awakens or not, we are already on the path of its awakening. We have left our footprints behind.